Today we're going to solve another quick problem about the ideal gas law, and in the next following videos we're going to continue on to study about the first law of thermodynamics. So I'm going to read the problem, and if you want you can pause the video and read it by yourself. You will have the problem down in the description, of course. So a container in the shape of a cube, 10 centimeters on each edge, contains air with equivalent molar mass of 28.9 grams per mole at atmospheric pressure and temperature at 300 Kelvin. Find under A the mass of the gas, under B the gravitational force exerted on it, and under C the force it exerts on each face of the cube. And that's about it. Okay, so let's see what we have here. We have that a cube that's filled with a gas, and we have that one side of the cube. That one side of the cube is 10 centimeters. So A is equal to 10 centimeters. Okay, then we have the molar mass of the gas, which is 28.9 grams per mole. Then we have the pressure, which is 101 kilopascal, and the temperature is 300 Kelvin. Okay, and we have to find under A the mass of the gas, under B the force of gravity that's exerted on the cube, and under C the force that's exerted on one side of the cube as a result of the internal pressure. Okay, so let's see how we can solve this problem. So first of all, we have the ideal gas law, which is P times V is equal to N times R times T. Now we have to find the mass, so instead of N we can write it as M over M, the mass over the molar mass times the gas constant times the temperature of the gas. And if we calculate that for M, we'll get that M is equal to P times V times M over R times T. And if you plug in the numbers for the mass, you will get that M is equal to 1.17 grams. So that's the mass of the gas inside the cube. Okay. Now, what about the force of gravity? Well, that's easy to calculate. That will be N times G, which will be equal to 0.0114 newtons. And we have to find the force that's exerted one side of the container. So then force of side will be equal to what? The pressure inside the container over the area of the gas. And now the area is A squared, since we're looking for one side. And then if we calculate that for the force that's exerted on one side of the cube, so F side will be equal to 101 times 10 to the power of 3 newtons, or that's 101 kilonewtons. And we are done.